Hello and good day, Algebra. We are here covering CO58 using something called the discriminant to gain information about a parabola's x-intercepts. We spent PO55 and CO56 talking about the x-intercepts of a parabola. PO55, we learned 3 different methods we can use to find the x-intercepts of a parabola, but sometimes it's handy just to be able to know how many x-intercepts a parabola has. And that's what the discriminant is for, okay? It says to gain information. The information that we're gaining by using the discriminant is how many x-intercepts a parabola has. And this is the discriminant. It's a key point, so it should be on a help sheet. B squared minus 4AC. B squared minus 4AC. And again, if you're wondering, well, where do A, B, and C come from? They come from the AX squared plus BX plus C, kind of like we used back in PO55 as well. If you're wondering where the discriminant comes from, PO59, which is about the quadratic formula, B squared minus 4AC is a part of that formula. And when you isolate it, as we are here, the information that it gives you is how many x-intercepts a parabola has. So we'll come back to this tomorrow, actually. But for right now, we're using just this part for this information. So when you plug in A, B, and C from a quadratic equation, and your answer is positive, doesn't matter what positive, but if it's positive, it means that there are 2 x-intercepts. Again, doesn't tell you where they are. It doesn't tell you what direction the parabola opens or where the vertex is or anything like that. Just how many x-intercepts the parabola has. If the discriminant equals 0, it means the parabola has 1 x-intercept, which does tell you a little bit of information about the vertex, because in order for a parabola to have 1 x-intercept, what does that mean about the vertex? Noah? It's on the x-axis. Again, doesn't tell us where, but that's on it. And then a negative discriminant means that the parabola has 0 x-intercepts. In PF55, we first talked about what it looks like for a parabola to have 2 x-intercepts, or 1 or 0, and so those same 3 numbers are showing up here. And so basically, CO58, you'll notice below here, I have you find the direction, the vertex, the y-intercept, the number of x-intercepts. We are combining everything that we've learned as far as characteristics of a parabola to really get a picture just from the equation, without doing any graphing, but just from the equation, get a picture of what these parabolas are going to look like when they are graphed. So the first one here, equation is 3x squared minus 6x plus 7 equals 0. Which direction is this parabola going to open, Brent? Up. And how do you know that? Right, that A term is positive. I'll write the letters up here too, A, B, C. If you want to, in the margins, write A is 3, B is negative 6, C is 7, just to help you, kind of simplify things and keep track of them. That's totally fine. But it opens up because the ax squared term is positive. What's the vertex of this parabola? Who remembers that vertex formula? Woo. Don't all raise your hands at once. I can't call on all of you. Quinn? Negative b over 2a. And what that gives us, right, is just the x value. We have to do a little bit more work to find the y. But negative b over 2a, which in this case, b being a negative 6, the signs will react to give us a positive 6 over 2 times a, or 2 times 3, which is 6. And so the x value of our vertex is going to be 1. How do we calculate the y value of the vertex? Brent? Plug it in. And your calculator is an excellent tool for this, right? This one with x being 1, you could probably just do mentally. But your calculator still, it's a good habit to get into using that. So to plug this in, again, I like to put my x value in parentheses, even though it's positive, just getting that habit. So 3 times 1 squared minus 6 times 1 plus 7 is what? What do you get? Quinn? I did not get 10. I got 4. This ends up being 3 times 1 squared minus 6 plus 7. I'm wondering how you... Oh, okay. Did you multiply 3 by 1 first and then square? So you got, yeah. So order of operations here, the squaring comes first. So you're squaring 1, which is 1, and then multiplying it by 3, rather than multiplying 3 and 1 and squaring that, which would give you 9 and ultimately 10. So, but yeah, 4 is what you should come up with. So if you're using a calculator and don't get 4, raise your hand, and I can come around or maybe ask a neighbor to see what you're doing wrong. But 4 is what you should get. Any issues? Okay. What's the y-intercept? What's the y-intercept? 7. It's that C value, right? 0, 7. Okay. And now we get to the new part, the number of x-intercepts. So our discriminant, b squared minus 4ac, I'm just going to write that down here, b squared minus 4ac. And I'm going to plug the numbers beneath that, what we're actually using here. So our b value is a -6. Again, I want to put that in parentheses. This time I need them. When I plugged in 1 to find the y value of my vertex, I didn't need the parentheses. This time you need them if using a calculator, because that b value is negative. And we're subtracting 4 times a, which is 3, times c, which is 7. If you plug it into your calculator exactly like that, it's going to be good. Okay? But already here, what can you kind of predict? Because remember, we're not interested in what the answer is. We're interested in the sign of the answer. Is it positive? Is it 0? Or is it negative? Without using a calculator here, is this going to end up with a positive value, 0, or a negative value? What's your prediction, Bridget? Why do you say that?
And the minus sign in between.
Yeah, -6 squared. That's a relatively small number, right? In the grand scheme of things. You can do that mentally. Maybe you can't do 4 times 3 times 7 in your head, but you can probably predict that 4 times 3 times 7 is bigger than 36, right? Okay. It actually equals 84. Right? So the answer that we're going to get from this, 36 minus 84, is a negative. And because it's a negative, we don't really care what the number is, so I'm just putting the sign there. Because it's a negative, it means that this parabola will have 0 x-intercepts. Check out my circle game, by the way. That's a pretty decent one. If I connected it at the top, that'd be a pretty good circle. Yeah. Okay? Questions on any part of that? Right? Just from the equation, we know the parabola opens up, we can calculate the vertex, we know where the y-intercept is, and we know how many x-intercepts it is going to have. That's the gist of what we're doing today. So, Ivy.
Wait, so if the answer you get from b squared minus 4ac is a negative, then it would be 0?
Correct. There are no x-intercepts. It does not cross the x-axis. Let's look at the next one. What direction is this one going to open? Up or down? Down. The a value is negative. That -2 means we'll open downward. For the vertex, let's start to calculate this. Negative b over 2a. B is positive 8, so in the formula that's going to be a -8. Divided by 2 times our a value, which is -2. So -8 divided by -4. Our x value of the vertex is +2. And if you need kind of practice calculating that vertex, you can go back to CO58. That's where I first talked about it. So we're plugging 2 into our equation. So we have negative 2 times 2 squared plus 8 times 2 minus 4. What do we get? Soybe?
4.
We have a second on that? That's what I got, 4. If you didn't get 4, go back and make sure you have a negative 2 as a coefficient. Make sure that, I don't know, you're adding 8 times. I mean, there's a lot of potential mistakes that could be made there, but 4 is the correct answer. Anybody want to talk about it? Okay. What's the y-intercept? Bridget?
0, -4.
Good. 0, -4. And the number of x-intercepts, again here, we're looking at b squared minus 4ac. So I'll write that. Plug in the values. Our b is an 8, so we have 8 squared. The parentheses aren't necessary, but I just do it out of habit. Our a value is -2, and our c value is -4. This one's not quite as easy to tell whether it's going to be a positive, a 0, or negative. But what do we come up with here? It ends up being a positive number. Again, we don't care what. The fact that it's positive means how many x-intercepts will it have? We'll have 2. It will have 2. Okay. You should get 32 as an answer for this, by the way. It ends up being, but again, it's not the number that we care about, it's the sign of it. So, yeah.
So on the test, do we have to write the full thing out?
No, the test is going to focus on the number of x-intercepts. I just like to, when there's an opportunity to bring something back and practice it again, I like to do that. So that's why we're also practicing the vertex and things like that, just to get you more comfortable with it. Any others of these, the remaining 4 on this page that look particularly entertaining? Bridget? The last one, why not? Is there a second page of this? Oh, there is. Fantastic. Okay, so the last one here. The direction, what direction will this open? Everybody? Down. That A term being negative tells us that. The vertex of this, we'll do a little bit of work for this one. So we got negative b over 2a as our formula, which gives us a -2 over 2 times -13. I must have been mad at someone when I wrote this one, which does not work out evenly. You get a -2 over -26, which when you simplify that becomes positive 1/13. Just be glad you don't have to graph this one. Okay, positive 1/13. Just as a sidebar here, is this parabola going to be narrow or wide? Very narrow, actually. Remember, the further away we get from 0, whether it's positive or negative, the further away we get, which in parabola world, -13 is pretty far away, it's going to just make it narrower and narrower and narrower. Okay, the closer to 0 we are, that's where it gets wider. But anyway, this is where your calculator comes in very handy. We've got -13 times 1/13, which is squared, plus 2 times 1/13 plus 6. And let me do it in mine. So fraction bars, if you want to write 1/13 as a literal fraction, it's that ABC key. Looks like this. Or you can also just do in parentheses. So you do 1 and then ABC and then 13. That treats it as a specific fraction. You could also do 1 divided by 13 in parentheses. Your calculator calls that 1 divided by 13, but it's the same thing as the fraction 1 1/13. So maybe yes.
Oh, I got 6u.
I have not done it yet, so just sit tight and we'll. It's gonna be nasty. I mean, there's no ifs, ands, or buts about it. But, woo, yeah. So what'd you get?
I got 6u1.
Okay, so if you use this fraction button, the answer that it gives you is 6, and then you what? Soybean? 1/13, like that.
It's like a slash.
Oh, it's the division symbol, like this. Yeah. So that's your fractions way of communicating a mixed number to you. This little U button here is 6 and 1/13. As a decimal, I get 6.076923077, which if I convert that to a fraction would give me this. So if you get 6 and 1/13, or 6 followed by a nasty decimal, then you've done it correctly. Any issues? Okay. So 1/13 and 6 and 1/13 for our vertex. Our y-intercept, 0, 6. And the number of x-intercepts, what we're really here for. b squared minus 4ac is the discriminant. Our b value being a positive 2 means we're going to square that and subtract 4 times a, which is negative 13, times c, which is 6. Without a calculator, who can tell me whether this is going to be a positive, a 0, or a negative value? Elise,
Positive,
how do you know that?
because there's 2 negatives in the section.
Right. And what happens when you multiply 2 negatives together? What does it become? A positive. So whatever negative 4 times negative 13 times 6 is, we're going to be adding it to something that we're squaring. We already know that whenever you square anything, it's always going to be a positive value. By definition of squaring something, it's got to be positive. So if we're starting positive and we're adding something, there's no other option but to end up positive. Okay? So it's mathematical tricks like that you can use to, rather than actually calculating it, since we don't care about what the number is, just its sign, you can use those. It actually ends up being, well, a pretty big number, 250 something or something like that, but it ends up being a positive. That's what we care about. Yeah?
On the test, will you be allowed to use a calculator?
You will be allowed a calculator on this test. That would just be viciously cruel to have you calculate a vertex of 1/13 and 6 and 1/13 without a calculator. Not even I'm that mean. Oof. Okay, other questions? All right. So the second page, and you can finish this as part of your homework. The second page is kind of where we put everything together in a different way. It says, write a quadratic equation that satisfies the given requirements. And so there's no single answer to any of these. Okay? There are a lot of different quadratic equations that you can write that have one x-intercept. But what must be true for that to happen? What characteristics would your equation have to ensure it has one x-intercept? Brent? Has to have a discriminant of 0, which means b squared minus 4ac has to equal 0. Right? The discriminant has to equal 0. Are there lots of numbers you could plug in for a, b, and c that would make this happen? Yeah. Pick a value for b. Pick a value for b. Yeah. 6. So if we make b 6, which makes 6 squared 36, we're essentially looking for a value for a and a value for c that multiply to make what?
36.
Well, just the a and the c part now, because the 4 has to be there. That's part of it. So what value for do a and c have to multiply to get, Brent? 9, right? Because 4ac has to equal 36, so that when we subtract that, it's going to equal 0. So what options do we have? We could do 3 and 3, or we could do 9 and 1. We could do 4.5 and 2, right? There's lots of different options here. Let's use 3 and 3, however. And what we've just done is we have selected values for A, B, and C. Right? We found values for A, B, and C that made this work. So our equation, which is in ax squared plus bx plus c form, has an A value of 3, a B value of 6, and a C value of 3. If we had gone with 9 and 1 instead of 3 and 3, then it would be 9x squared plus 6x plus 1. Right? But the one thing that must be true to have one x-intercept is right here. The discriminant has to equal 0. And so we plugged in numbers. We really just kind of guessed and checked here. Plugged in numbers that would make that happen. And then use those values for A, B, and C in our equation. Does that make sense? Is that okay? Pick another one on this page that looks a little bit interesting. Brent.
One x-intercept and a y-intercept of 0.
Okay. Which one is it? Oh, one x-intercept and a y-intercept of 0, 12. Okay. So the fact that we have one x-intercept means what? What must be true? We'll deal with the y-intercept later. But what must be true if we have one x-intercept? The discriminant has to be 0. So once again, we're kind of looking for values that make this equation true. B squared minus 4ac has to equal 0. But unlike last time, we already know what one of those variables is, right? Which variable are we given a value for, Gavin? C. With a y-intercept of 12, that means that C has to be 12. So b squared minus 4a times 12 has to equal 0. And you get to kind of fill in the rest here. Four times 12 is already 48. So b squared minus 48a equals 0. We need to find a multiple of 48 that's also a perfect square. Right? In this case, we can't just plug in, say, 6 for this and say 36 minus 48 times what equals 0, right? It has to kind of flow better here. So multiples of 48, we have 48, obviously. 96, is 96 a perfect square? No? 96 plus 48 is 144. Is 144 a perfect square? Bingo. Okay? So, what number times 48 gives us 144? 48, 96, 144, 48 times 3. Okay? So our A value has to be 3. And what number squared equals 144? What's our B value need to be here? 12. Put it all together, and we get 12 squared equals 4 times 3 times 12. Okay? What we did was we started with what we knew had to happen. We knew that b squared minus 4ac had to equal 0. We plugged in what we knew. We knew that c had to be 12 because of this condition right there. Okay? So with that, we had to find some value for a and some value for b that made these two things equal. So that when we subtracted 48a from b squared, it's going to equal 0. So we went kind of through the multiples of 48 to find that perfect square. 48 times 3 gave us 144. which is a perfect square, and that's how you got 12 squared, which is 144, equals 4 times 3 times 12. So our final answer, with a b value of 12, an a value of 3, and a c value of 12, we've got 3x squared plus 12x plus 12. Could I also write 3x squared minus 12x plus 12? Just to be different. Would those two equations work out the same? They do. Because in the discriminant, b squared, whether we square a positive 12 or a negative 12, both those numbers when squared give us a positive 144 here. Okay? With the a and c not changing, it doesn't change what happens on the back end of this. Right? So this, admittedly, this is kind of an extension thing here. Okay, this is kind of, do you really know your parabolas and all their characteristics and how you use the equation to find them? And I should have prepped you for this. I should have warned you. This is like the culmination of everything we've done so far this unit. Okay, but the nice part is, there's more than just one answer here. There are lots of different ways you can get to what you want to get to. You just have to know how to get there. So I expect us spending some time on correcting this one tomorrow. If you can't figure out the equation, I'll forgive you for that, but don't come in tomorrow with a blank page or a couple not finished saying, I didn't get how to do it. At the very least, I need you to fill out this section here, the what do you need? What gives you 2x intercepts and what tells you whether it opens up? So you can't get the equation, okay, but at the very least, you need to tell me what you need to make these things happen. What do you need for no x-intercepts and 6 as the x value of the vertex? What characteristics, okay? Soybe, your homework is both pages, finishing the front of 58 and the back side here, again, on the second page. On the second page, I'll forgive you if you can't come up with the exact equation, but I need to see that you understand what characteristics are necessary to make it happen. Alrighty. Questions, comments, concerns, complaints, comments, congratulations. Certainly there are criticisms. How dare I? Yeah. Well, we are looking for a deep understanding. We're looking for a deep understanding of parabolas here. Deep understanding. Okay, that's all I've got for you. Homework for tomorrow is CO58. That's how you math.